Let's look at an example of using related rates with the geometric shape of a circle. The stone is dropped into a calm body of water, causing ripples in the form of concentric circles. So that tells us we are dead set on circles. The radius of the outer ripple is increasing at a rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? Well, I have 7 steps that you could follow to do these problems. Some of these steps need to be in a certain order. A lot of times these steps don't have to be in a certain order. I'm going to do this first example using these steps in this order. Number 1, translate the phrases of the sentences into calculus. First sentence, the only thing that's important there is mentioning that it's a circle. There's nothing to convert into calculus. The second sentence, the radius of the outer ripple is increasing, that means positive, at a rate of 1 foot per second. When you're given a rate, you should write that rate using Leibniz notation. So the change in the radius with respect to time is equal to 1 foot for every 1 second. The radius is increasing at a rate, change in radius with respect to time, 1 foot per second. The reason that we know radius goes on top, it's mentioned first. Secondly, look at these units. Foot is first. And secondly, seconds is mentioned. That's on the bottom. Seconds is referring to time. So we have just taken that sentence and we converted it into calculus. Last sentence, when the radius is 4 feet, at what rate is the total area of the disturbed water changing? That is telling us that we need to find, it says at what rate is the total area. We need to find the change in the area with respect to time at a specific instance in time, and that instance is whenever the radius is 4 feet. Comes from right here. Whatever you're supposed to find is the catalyst for this entire problem. This tells us that we have to have some type of an equation that uses area. Number 2, identify all the variables involved in the problem. Well, just looking at these letters, I have R is for the radius, and those units are in feet. T is for time, and those units are in seconds. A is for area. Now, if the radius is in feet, that means this area is going to be square feet. 3, identify which, if any, of the variables in the problem that remain constant. So of these variables, like if the radius never changed, that would be constant. But if you throw a stone into a body of water and it's causing ripples, it's not going to remain constant. Time, I couldn't imagine ever being constant unless you could stop time as we know it. Only Superman can do that. And the area is going to be changing all the time because these circles are getting bigger and bigger because you dropped the stone into the water. So part 3 over there on the side does not apply. Part 4, if it's a multivariable function, find the value of the other variables. I probably should have written that after step 5, but let me just tell you it's not going to apply to this problem. Number 5, write an equation from your brain. Now, this equation has to relate to this problem. You want an equation that uses as many of these variables as you can, but time is not going to be one of them. So area and radius. Hopefully you know what the equation is for the area of a circle. Area of a circle is pi times the radius squared. Some more things that go into that that I don't need to mention for this problem. 6, implicitly differentiate both sides of the equation with respect to time. So we are going to, this will be step 6, We're going to take the derivative of the left side of the equation and the right side of the equation with respect to time, which we practiced in the introduction. On the left, derivative of a is 1, but if it's with respect to time, that's going to be change in a with respect to time. On the right side, the derivative of pi r squared, that would be 2 pi r. Keep in mind r is the only variable here. Pi is a number, and so is 2. It's the incorrect variable, so we multiply it by the change in r with respect to time. That's implicit differentiation. Step 7, substitute all instantaneous rates and values of the variables and solve the remaining rate or variable. So we were told we want to define the change in area with respect to time. That's already by itself when r is 4. So now let's say we're going to find the area with respect to time when r is 4. So on the right side, we can replace the radius with 4. And if we're fortunate enough to know what the change of the radius is with respect to time, we sure are. We're told that right here. We can plug that in and get that that is 1 foot per second. If you were to simplify this just a nubbin, you would get 8 pi. Every time you get an answer in which there are units, you need to put units in your answer. What kind of units would area be in? We said at the top, area is in square feet. What kind of units is time in? We said at the top, it's in seconds. Here's what this means. When the radius is 4 feet, the area of the circle is increasing by 8 pi square feet every second. It's an instantaneous rate of change. That concludes a circle example. The next example I will do is for a cylinder.